can go ahead and get started on this lesson. Okay, so this first one is going to be on lesson 873 of your Saxon, and we're going to go ahead and look at this example. It says, consider the sequence of 5, 10, 15, 20, and then dot, 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 meaning it'll go on forever or until it says stop somewhere. So the table of number of each term and its value is shown below. So the number of term n and then is 1, 2, 3, 4, and the value of term A is 5, 10, 15, 20. So what they want us to do is, so that they want us to graph the sequence. So graph the sequence. So this is a sequence right here. Now it says right here, sequence. So that means that the first term, so first term is 5. The second term is 10, and the third term is 15, right? That's what a sequence is. It means it's going in that order based on a formula or based on like some type of code that will give you like the output, which is this. So it says graph the sequence. We can graph the sequence by graphing. Just going to put this so that you guys can see. Graphing the pairs of NA. So what this means is that N right here is kind of like our X, and then A is our Y. So that means that this N is our what we're inputting, and then A is output. Okay, so then that we can graph this. I move this over here because I do not want this to see. So then I can graph this maybe on right here on the side so that you guys can see. Why is this so hard? Okay. Put this in a different color. So then this would be our number of terms. So this would be n, and this over here would be our our value actually. Value of term, which is A. Okay, so then we can do something like this. We can do 1, 2, 3. Oh, that's a little ugly. 1, 2, 3. And then this one can be by 5. So there's 5, 10, 15, 20, and then so on, right? So and then our first one would be 5. Is that correct? 5. Our second one would be 10. Third one is 15. And then, right, it goes on and on and on. So that's it. That's all we do. We just graph it. Okay, so I don't know why I keep doing that. Okay, so the first example says graph the first 5 terms of the sequence, and the sequence is 1, 2, 1. So I'll go ahead and write this as I'm speaking. So what I'm going to do is I'm going to do oh Lord, what is that? I'm going to go ahead and make like a chart so that we can so this is going to be our number of term, which is our n, right? So it's the first term, second term, third term, and then this is going to be our value. of term. And this is represented by A. I don't know why they wanted to do like that, but you guys can just put X and Y. So our first term is 1. Our second term, right? Second term is half. Third term is 1/3. Fourth term is 1/4. Our fifth term is 1/5. Okay, so now it's telling us to graph it. Okay, so I'm gonna make the graph right here. And I'm gonna put, so this is our N, and this is our A. And then so I'm gonna do 1, 2, 3, 4, 5. So 1, maybe I can make this a different color. 1, 2, 3, 4, and 5. Okay, so and then I'm gonna do make this actually. So this is going to be 0.5 and then 1, right? So we can write this. This is 1. This is 0.5. This is 0.33. I'm just converting these fractions into decimals, so it'd be easier to graph. Okay, so then I can go ahead and graph this. Okay, so I can put what I'm graphing here. So this would be 1, 1. This would be 2.05. This would be 2, no, not 2, sorry. 3, 3, 3. This would be 4.25. This would be 5.20. Okay, so these are what we're graphing. Okay, so our first point is going to be 1, 1. Our second point here is 2, and then 0.5. Third term is going to be somewhere right here, right in between. So this is probably like around right there is 0.33, and then 0.25, and then point. So we're just kind of estimating this right here. That one's probably 0.25. So this is going to be right here. 4.25 be right here. 5 be right there. So it looks like it's like decreasing gradually, and it's heading towards. So if we plot this, it would look like this. And it's going to be lower, 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 right? Be closer to 0. Okay. So, but we don't really have to connect the line if you don't want to. It's up to you. Okay, so then we can go to the next example, just to help you out a little bit more. Okay, the next example states, graph the first 3 terms of the sequence, an equals 3n. So then, so first, as always, let's go ahead and make a graph so that it would be easier to graph. So if we make a graph here, so then this is obviously the number of term, which is our n, and value of term, which is a. Then what this means, an equals 3n. Then when n equals 1, so a1 equals 3, 1. So then this is 3. when n is equal to 2, an is equal to 3, 2. So I'm just plugging in the number, you see? See how I'm just plugging in that number? Okay, so when an equals 2, then, oh, I forgot to put here. This equals 9. So when n equals 3, an is equal, why do I keep doing? A3 is equal to 3 cubed, which is 27. If you guys don't know what I'm doing, the reason why this is 3 is because 3 squared is the same thing as saying 3 times 3. So then 3 cubed is the same thing as saying 3 times 3 times 3. So then when n equals 4, a4 is equal to 3, 4, which is the same thing as saying, so 3, 4 is equal to 3 times 3 times 3 times 3. So it's 3 4 times. Okay, so what you guys can do is 3 times 3 is 9. 3 times 3 is 9. So 9 times 9 is 81. That means that 3, 4 is equal to 81. Right? Okay, so then that we can put this inside our chart. Okay, so when n equals 1, then remember right here, it was 3. When it was 2, it was 9. When n is 3, it was 27. When it was 4, it was 81, and so on, right? Dot, dot, dot. And we don't have to go anymore. We can stop right there. Then now we have to go ahead and graph this. So now we can graph this right here. And we're just going to graph it too. So remember, this is our n, and this is our a. Then do 1, 2, 3. So 1, 2, 3. Okay, and then I'm going to do, let's go ahead and do by, should we do, what was it? So we'll do by 5. So 5, 10, 15, 20. Well, I'm doing it small because we have really large numbers. 40, 50. Probably won't go higher than that. Okay, so let's go ahead and graph it. I'm going to have my chart, both of them here at the same time. Okay, so when n was 1, this one was 3. Oh, that's not really good. Put it right there. When n was 2, it was 9. And it was 3, it was 27. Right? So it's like growing. It's increasing rapidly, really fast. I can go ahead and zoom this so that everybody can see what I'm talking about. So then this chart, it's increasing super fast. Just in case I ask you guys, how fast is the graph growing? Then it's increasing rapidly, right? Okay, so that's it. We can go ahead and do some problems. Actually, let me do another problem. Let me do another problem right here. I'll do it right here. Okay, and our next problem says, graph the sequence. So this is part of your lesson practice. So this is what you'd be doing on the forms. So the lesson practice, it says actually all of them say, so graph the sequence. So it's telling us what we just did right now on the problem. So our first one is 3, 6, 9, 12, dot, 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 dot. Okay, so if you want, you can do the same thing. This would be n, the number of terms, and this would be the value of term, which is a. So our first term is 3, our second term is 6, our third term is 9, and our fourth term is 12. Okay, so then we can go ahead and graph this. Let's go ahead and graph it right here. So this would be 1, 2, 3, and 4 right there. So this would be, I'll do it by 3, 6, 9, and this would be 12. Okay, so and then our first term is 3, second term is 6, third term is 9, and our fourth term is 12. So it's increasing linearly, right? Increasing at the rate of 3, right? So this would be 3 and would be our formula. So when we plug in 1 here, it would be 3. When we plug in 2, it would be 6, so forth. So that would be our formula, but this is what your graph should look like pretty much. Okay. So